All right, it's 7 o'clock. Let's get started. This is the 7th week of our class. We have one more week left. Before I started the class, I really wanted to do a review. So can anyone talk about these few things about the recursive function? Anything you remember about the recursive function? Can talk about that. Do I get a volunteer?
I think the function like calls itself again.
Right, yes, it calls itself, yes. So what else do you remember?
It stops when it reaches the ideal value that we're trying to get.
Right, yes. So this is the best case. If it reaches the best case, then a value will be returned and it will stop.
It has to return or something, like at a certain time it has to like.
Yes, it will return something. If it does not return, then why do we do recursive, right? So recursive function will return. And another feature of it is that when it calls itself, it does it in a shrinking way. So it shrinks in order to reach the best case. So remember that 3 things for a recursive function. Number 1, it has to call itself. Number 2, when it calls itself, it is in a shrinking way. So that's why it will reach to the best case. Number 3, this is the best case. When that case is reached and it will not call itself anymore, it will stop there and it will return the value at the best case. All right, so anything do you remember about the construct of a class and what is it used for? So first, what is the construct of a class? That's right. Jing said it. Underscore, init, underscore. Yes, that's the construct of the class. That method is a constructor. Let me ask another student. So, Emma, so what is the constructor used for? Do you remember anything?
It's used to make a class, and in a class you can store objects like strings, functions, stuff like that.
Yeah, a class can store attributes, variables, and the methods, functions. Okay, so what is the constructor used for? What is the constructor used for? So let me see. Serena, do you remember what is the constructor used for? Serena.
I think I forgot that part.
Okay. All right. So Stephen Wang.
I don't really remember.
Okay.
I know how to create a class, but I don't remember what
I
it's
think it's like creating an object or something.
Okay. Wing, can you just show your homework? So let's take a look at the homework, then we will, you know, brush on what does the constructor used for, okay? So Brian, I stopped sharing. Can you share your homework?
Okay. Okay, can you see it?
Yeah, I can see it. Can you just walk through it? Talk about what you did.
So I just made a class called person, and it has 3 attributes: age, name, and happy. And when it's created, you can create it with those 3. And there's 3 functions in it. They're greet, sleep, and introduce, and basically they just do like normal person stuff and print out stuff. So like if I run it, it prints out that.
Very good work, Brian. You see the homework asked for 3 attributes. So can you point out which 3 attributes you have, Brian? Yes. So it has an age, it has a name, it has the variable happy, okay? So when you make it an attribute of the class, you see in the left side, on the left side, you use a self.age, self.name, self.happy. So that way you make the age, name, and happy the class attribute. And the constructive, the init method is used for initializing the value for the class attribute. So when you create a class, if the class has attributes, and if the init method is defined that way, then you have to provide the values for those attributes. Okay, so that's why we needed to use a constructor. Okay, if you do not have attributes, and then you do not need to use the constructor. The constructor usually is used for initialize the value. And in the homework, I asked for 3 attributes and 3 methods. And Brian, you defined 3 methods. Actually, we see 3 functions. When the function is in the class, then we see that function is a method. So you define 3 methods, 3 attributes. And I reviewed some homework, and you really do not have 3 attributes and 3 methods. I do not know why, if you get my requirements or not. You don't have to do a lot in the method, right? You just show me that you understand the requirements. So because you see Bruin has 3 methods in it. Okay. And for some students, he or she define the init method multiple times in a class. In Python, you cannot. In Java, you can. Java, the method can be overloaded. Okay, in Python, if you have a method has that name, and then you created the same method, that will be a problem. That will be a problem. Okay, remember that. Thank you, Brian. All right, so now let's move on to today's material. Today, I think conceptually, there are something very important to us Also, there is a part that is very hard, so be prepared, okay? So it's more like a lecture. So let's just move on. So first thing we talk about a nested class and the inner class. So what is a nested class? It's a class defined within another class. You see, when we do function, we have a nested function. That means a function in another function, all right? Here is a class in another class. Why do we do this? What's the benefit? So the concept, conceptually, this is very straightforward. You have a class called, let's say, outer class. And then you have a class called inner class, okay? The name really doesn't match, but the structure. You say this is a class, and this class is within that class, okay? So that is called a nested class. A nested class does not have access to the outer class member. So what does it mean? If you have an attribute in the outer class, you cannot directly use it. You cannot directly use it. So if I have a variable called x in the outer class, you cannot just take it for granted that you can use x in the inner class. Okay, you cannot do that. All right, so remember that. So let's see some example. You say I have a class called a human, and then I have a class called a head. Okay, a human has a head. Head is also a class here. But you see, we have name, and you do not see that I use name here in my head class, right? And it just the powerful thing you can see here is that I have a lowercase head. That's a variable, and this variable actually stores this class and the instance of this class. You see, it creates an instance use h the uppercase head. Okay, so this lowercase head stores the uppercase head instance. So let me give you this code and I want you guys to run it, see if this makes sense to you. Right, go ahead and use this. Sorry about that. Let me use WordPad to change the format. Okay. Go ahead and run it. See if this makes sense to you. If you have any question, let me know. Okay, this code you say you create an instance of the human and store that in Guido, and then you print out the name, and then you say you use Guido head talk. So you use the inner class method. Okay, you say you use it that way. Try that. So let me save it and run it. Okay, Guido talking. Any question? Okay, if you do not have question, then let's move on. This is in the class. Now let's move to the next topic. And I do not want to just read through these slides. So why do we use in the class? The benefits is that for you to organize the code. And if the inner class actually is not used in anywhere else, so only the outer class will use it, then that's the way to use the inner class, okay? Do not have to go through all the slides like this. Let's just tell you why we need to use inner class. All right, so the next one is very important. Actually, you know, it will be one of the cornerstone of Python. Actually, I should say the cornerstone of all object-oriented programming. So let me get a student to read this slide and help me. Let me get one student. David, can you help me, David? Here, can you help me read this slide?
Instead of starting from scratch, you can create a class by deriving from a pre-existing class by listening to the parent class in parentheses after a new class name. The child class inherits the attributes of its parent class. You can use those attributes if they were defined in the child class. A child class can also override data members from methods from the parent.
Right. So why do I say this? This is the cornerstone of Python, because you see, when we do coding, we use object a lot, and then when you see the object, you have a lot of attributes and the methods, and then you see the relationship between the parent class and the child class. That makes your code very powerful. And why it is powerful, I will show you some example, okay? So let's just move to the next slides. Because there's a parent class and the child class, so the child will inherit everything from the parents. Everything from the parents. So okay, the inheritance allows us to define a class that inherits all the methods and the properties from another class. So parent class is the class being inherited from, also called a base class. Child class is the class that inherits from another class, also called a derived class. So let's see an example. So I have in the class, I name it a parent. Actually, you can name it differently. And I have another class called a child. I'll name it a child. You can also name it differently, but please pay attention to this line of code. You see, when I say class child, I have the parentheses here, and I put another class name here. So if you do that, you make this class the parent of this class. Okay, so the class in the parentheses will be the parent of the class you define. All right, so let me give you the code, and then let's do something and investigate on this, okay? See what difference it makes. Let me give you the code, and I want you all to run it. Fine. So you see, I have code here. And then in the next slide, I will ask you to do something, okay? All right, so let me show my next slide. Now let's try to create an instance of the child and an instance of the parent. You will see that the child has methods defined in the parent. So let's do this. So let me do this. A parent equal to parent. Okay, you create an instance of the parent. Now you create another variable, okay? It's an instance of the child. A child equal to child. Now you create two instances. All right, so now let's pay attention to this. You see, in my child class, I only defined the two methods, child method and the init method. But in the parent, let's see what we defined. We defined a property called the parent attribute. It is equal to 100. Then I have the init method. And I have the parent method. I have the set attribute method. I have the get attribute method. So I have 1, 2, 3 methods plus a constructor. Now let's see what happens. So you have an instance of the child. Can you do a child? Put in a pointer here. You see what happens. You see the child also has an attribute called a parent attribute. Actually, the child did not define it. This exists in the parent class, but you see you automatically inherited it. So you also have that attribute. Same thing, you see you have a method called set attribute. You have a method called get attribute, right? And then you will see that you have a method called parent method. You really do not define those methods. They are defined in the parent, but as the child, it inherits all those things from the parents. So it automatically inherits that. So now let's just do a little bit more. Let me put in a dot here. And you see there are a lot more methods. They are not defined in the child. They are not defined in the parent. But why do we have it here? Because object is the parents of all. If you do not define a parent, then your class is the child of the class object. And all those methods are defined in class object. When I say object, I mean this one. Okay, I mean this one. So this class called object. Object has all those methods defined in it. So that's why you see a lot more methods there. Okay, what does this make sense? Well, if it makes sense, then can you run a child class instance and then you use the method of the parent and do something, just call a parent method, see what happens. So for me, let's say a child. And I will say set attribute, right? And I give it a value like a 20 now. Okay. So now let me print out a child. Parent attribute. Let's see what is the new value now. So let me save my code and I run it now. You see, okay, when I run this, you see what it prints out? The calling the parent constructor, okay, because you create an instance of the parent. And then it calling the child constructor because you create an instance of the child. Now you set attribute 20. So the parent attribute, the original value is 100. Because you called this method, you see the change that value to the value passed in. That's 20. So now when you print out the parent attribute, 20 is printed out. 20 is printed out. Make sense? Let me stop here. And can I get like 2 volunteers to show me your screen? See how you are doing. This is one of the most important concept. And actually it's the cornerstone of Python or any object-oriented programming, the inheritance. Okay. If nobody, so let me get one student. I will call the name. So Jason, can you share your screen to me? Hi, Jason. All right. Jason, are you still there? All right. So Nathan, can you share your screen to me?
Okay, so oh,
Can you? So can anyone tell me why Nathan has a problem here on 18? Do not feel bad. I'm not trying to put you on the spotlight. Actually, this is a very good concept, so I can teach students here in this place. Okay, I'm not saying that this one you did it is something very bad. Okay, that's the class. Anyone from the class, do you know what is the problem here? Okay, so the issue is that I think when you try to use the class, you have to create an instance of it. So now you directly use child, and then that's not right. You cannot directly use child. You have to say a child equal to child parenthesis. That way the child becomes an instance. We say you create an object there. You create an object of the class. After that, now you can directly call a child dot set attribute. Because you use the instance, you cannot directly use the class itself. Okay, now you changed the value. So now you want to see if the values really get changed or not. So you want to print it out and see what happens. You print, use print. When you see set, you cannot just use print a child set. So you start a new line, yeah, print. And then a child, then the parent, no, a child dot parent attribute. And that way you will see that the parent attribute value get changed. Okay, good, thank you. So I hope that you get it done. Miss He is not here, so I do not know what Jason is. What are you doing? And I cannot get to your parent because I have to teach. If Miss He is here, then I will ask her to check. All right, so let's move on. This is a very important parent class and child class. You can also override the method in parent by redefining it in the child, just like the behavior of the init. Okay, you come back to see, you see the parent class here, you have the init method. It will call the parent as, it will print out calling parent constructor. You see here in the child, you also have the init method, the constructor. And you redefine it, and this will call the child constructor. All right. So if I take this out, look at my screen. If I take this one out, delete it. Now let me rerun my code to see what happened. Let me run this one. All right. Hopefully you can see the difference here. You see this print out twice. Why? Because you create an instance of the parent, and the init method is called. Then now you create an instance of a child, because the child did not define a constructor, so it will call the parents constructor. So that one, this one is called. That's why it also print out the parent construct. So it print out calling the parent construct here. Because the child does not have that method, you use it now, it will use the parent's version of that method. Hope that this is clear to you. So this is really important. So let me pause again. And if you have any question, let me know. Okay, let me put this message back. Any question? Okay, so you say you have the method in the parent, and the method behavior is doing that. If you redefine it in the child, you can change its behavior. You see here, the behavior now prints out a different thing. So this, this action, we call it override. So you redefine it, you override the version in the parent. You override it. So you have your own version. It's called override. Okay. So let me give you like 3 minutes. You say that you have 3 extra methods in the parent. Can you guys override another method of the parent? And I give you 3 minutes to do it. Just override another method in the parent. You do that in the child. So in the child, override any method in the parent. Anyone, pick one, and then define your own. And then I will ask 2 students to share the screen. I wanted to check. I want you to do this to understand what it means. All right, so let me stop sharing. 3 minutes, okay. I will check at 7:37.
Are we changing the Are we changing the class that you put in the chat or the one we did for homework?
The one I put in chat
Okay.
today, yeah, I just give you the code, the parent and the child. You just add one more method in the child. The same, the method name should be the same as it appears in the parent, but you override it so it can do something different. All right, 10 more seconds. Anyone wants to volunteer? Okay, nobody wants to volunteer. So Jack, can you share your screen? Jack. Yes, so let me see. Yep. Good, you just override the parent method. Good work, good work, thank you. Dylan, can you share yours, Dylan? Dylan. Okay, let me just write down this two students' name. When I ask them, I do not get any response. All right, so grandparent, can you share your screen to me?
I didn't finish.
Even you have not finished, that's okay. But anyway, okay. Jennifer then. Jennifer, how about you?
I'm not completely sure if this is correct, but like.
Yeah, the way you do it, it's okay because so override actually just to redefine the method, do whatever you think is right. In the real world, when you when you get the attribute pass in, you really want to use that attribute. At least you see print attr, right? So that variable can be used. But um, theoretically, you are right. It's not. It's okay. Not a problem. Good. Thanks. Let's move on. All right. So you can also add a new properties and methods to the child, just like the ones in the child method you added. You can add a lot more. Okay. So the child can inherit everything from the parents, but the parents will not be able to use anything in the child. Okay. It cannot see it unless it creates an instance of the child, then it can use it. Okay. So the members in the child, I say the new members you create in the child will not be visible in the parent. Okay. But everything in the parent will be visible in the child. All right. Move on. We need to learn another one. It's called a super. When you do a class and do a child class, the super returns a proxy object. It's a temporary object of the super class, the parent class. Okay. This will allow the developer to access methods of the base or the parent class. What does it mean? If you want to use the specific version of the method of the parent, then you need to use the super. Why do I see that? Because right now you have a method or you have an attribute that is an overridden version of the parent. So if you wanted to get the behavior of the parent method and the attribute value, then you need to use the super. So what does it mean? Let me give you an example. So you see here you have a class called a dog, and its parent is Canada family. Okay, so that's a parent class. So now in this construct, you print out a dog has 4 legs, and then you see you use super dot init dog. Okay, so this version, this init method is from the parent. So how do you use it? You use the parents method, and then you put the super here. So that will get the parent version of that method. Okay. So that's the way to do it. So the super will return a proxy object. All right. So let me do a quiz here. So which of the following can be used to invoke the init method in B from A, where A is a subclass of B? I think this should be straightforward. We just talked about it. All right. Sebastian? Sebastian,
I'm not sure.
you're not sure. Take a guess then.
B.
B. So uranium.
Wait, I think I know. Can I take a guess?
Yes, please.
C.
C. Okay. All right. So how about uranium? Which one do you think?
A.
A is the right answer because you see A is the child of B. And now you wanted to get the init method of the parent. So that's why you use a super. Okay, you cannot pass yourself, okay? All right, move on. Next quiz. Or next slide. A class in Python can have multiple parent classes. In Java, you can only have one parent, but in Python, you can have multiple. So all methods and the properties of all parents will be inherited. So how do you create a child from multiple parents? I will show you an example. So if the parents have properties, all methods of the same name, that will be a problem, right? You see, if animal is the parent of a dog, and then the beast is the parent of a dog, and this method called go run, and this in an animal, and this another method called go run in beast. So then which one should I use, right? There will be a conflict. So this is a rule. If the parents have property or methods of the same name, and the child does not defend its own, if the child defends its own, that's fine. Always the child's version will override. It takes priority. So if the child does not defend its own, then the one from the parent which appear before the others will take the order. So what does it mean? What does it mean? Let's go to the next slide. Okay, you see I have a class called a dog. So it has two parents, non-marine mammal, non-winged mammal, okay? So if they have the same method, then this one take the priority. It comes before that one, okay? So it uses that order. Whoever comes first, who is in the front, that one will take the priority. Okay, move on. So these several slides are for advanced students. So we have about 10 minutes to go. So if you do not understand this, that is fine. If you understand it, then that's very good. It's already for advanced, but it's very important as well. Okay, so for a class right now we run into, we never put in a new method in it, right? New, but if you come in here, let's try this. Let me just put in a child. You put a dot here. Okay, do you see any method called new? You do see it, right? This method is defined in the object. Okay, class object. So you do see it, so you can use it. So what does it mean? So this is very important, okay? So I want you to pay attention to this. If you have a question, you can stop me anytime. So the new method in Python class is responsible for creating a new instance object of the class. So far, what we talk about is the init method. It is the constructor, right? But actually, this method does the creation work. It creates an instance of the class. Like Nathan showed to us, if we go directly use the class name and we use that method, it will be a problem. You have to create an object of it. An object is an instance of the class. So you have to create an instance of it. How the instance is created, the new method does that. But we do not have the new method in our class because the object already have such a method. So if you do not have it, it will go and pull it from the parent and use it, okay? So what does the new method do? Usually you see this the new method do, okay? So the new will return an instance of your class. You see this one, we use the parent's new method, right? So what does it do? You pass in the class name. The class represent your class, the current class. So it will create an instance of this class. It will create, okay? And then you can have a method called it, okay? So we pay attention to the new method. So this is, if you call the parent, then you need to pass in your class, okay? You pass in your class. That will guarantee you create an instance of this class. All right, so let's move on. So the first parameter class, CLS, represents the class being created. Here, the animal class, okay? Why is it the CLS rather than the self? Because the instance object has not been created, so that's why you cannot use self. There is no such thing when you call the new method. The instance has not been created, so self does not make any sense. So that's why, you know, you use CLS, the class, okay? And actually it does not exist while the new method is calling. Using self inside the new will make no sense, okay? So let's move on to the next slide. So the instance method, init, is the initializer of a class. So you already have the instance created. Now you can set its value. So it's an initializer. It does not create the instance. So it is the best to set initial values to attributes of an instance object in the init method. So do not set the value in the new method. Set the value in the init method. It's very hard, right? Right. So let's move on then. The init method does not have to return a value. The init method usually does not return. It is just used to set the value. But the new method does return. You see, if I move back to this one, this is a new method. It has to return. That's the way for you to get an instance. You needed to have an instance of it, right? So that's why it returns. Because it returns, then you say you can control it. So what does it mean? So you can return a different instance of a different class. Of course, that will cause problem. I will show you. But in the new method, you can set the value, but you usually do not do that. So you can set the initial value in the new method, but it's better to do it in the init method. So I will give you an example. But let me finish the slides. So if the new method of your class returns an instance of a class, then the new instance's init method will be invoked automatically. And the same arguments, okay? Do you still remember this? Variable lengths of arguments, variable lengths of keyword arguments, okay, will be passed to the init method as well. Okay, so hard, right? So let's move on. And so what does it mean? So I will give you the example to show the result. So if the new method of your class does not return an instance of the class, then the init method will not be called. So it allows you to take more control over how new instance objects are created and to return an instance object of an entirely different class if you like. So you can return a different instance of a different class, as I mentioned. So let's just do an example like this one. You say you have a class called A, and it has a new method, has an init method. You say the new method returns an instance. So once you return this instance, then the init method will be called. Okay, so let me give you something. Give you this code. And I want you to see the effect of it. Okay, so let me run this. You see here, I wanted to create an instance of class A. I will just use this, my A equal to A. You just create an instance of A, and you will see this will be printed out, and this will be printed out. Okay, let me show you. We run it. You see both are printed out, right? Because when you call new, it will return the instance, then it will come to invoke this one. Okay, so let me create another class here. B. And I really don't want to do anything in the B. I just want to show you. All right, so now if I just say return B. Okay? And then now you will see that this will not be called because you did not return an instance of A. You return an instance of B, so the init method is not called. But now you will have a problem. You will say if I define another method here, okay, I will say A method plus. So now you want to create an instance of A, but let's see what I have. Right? You say you still have this method in it, but what actually you got, what actually you returned is B. Okay? So that's why you got a problem here. You got a problem. Okay, so to make it more clear, so you will say my B equal to B. And then now you return my B. And then now you see problem is bigger. right? You say what you should get actually is a method of it's an instance of B, but actually you still get this one. So it messed up all the things here. It messed it up. So you have control here. You do have good control of what you can return. But you know, if you do not return it, the instance of this class, you got a problem on it. So let me move on to the next slide. Let's finish this quickly, okay? So here you see I have a class called animal, and it require name. You see I use new to initialize the value. I said it's not suggested, it's not recommended to do that. You should use the init method to do it, but actually you can use new. You can do it in new, okay? You can do it in new. Because you see you use this variable to store the instance. Now you set the value for this instance. Okay? So I think this is the most difficult part in my entire class for level 1 and level 2, this concept, okay? So the last slide is just to help us, I can summarize what I have told. So let me just do the reading. So if both init method and the new method exist in the class, then the new method is executed first and decides whether to use init method or not. Why? If the instance return is not this class, then the init method will not be called, right? Because other class construct can be called by new method, or it can simply return other objects as in the instance of this class. So what does it mean? Let's try this. Let's just try a method define B method. Let's say pass. Now let's see if we have a B method here. We don't see it, right? So it's the messed up. Okay. So just want you to understand this. I know this is very hard, and but you need to keep that in your mind. New is the actual method to create the instance of the class. Init is just to set its initial value. We see it's a constructor, okay? All right, so move on to the homework. So you all did homework last week, then it will be very easy for you to do it this week. Think about a class with set at least 3 attributes and 3 methods. That's what you did last week. Then create a child class, which derives from this class. You need to override at least 1 method in the parent. Do not just override the init method, okay? So at least 1 method in the parent. I already asked you guys to do it during this class time. So you need to add at least 2 new attributes to the child and 2 new methods to the child, okay? 2 more attributes and 2 more methods. Remember that? This will be the homework. Homework, I think, is not hard at all, but I really want you guys to go and practice on it. So let me stop here. If you have any question, let me know. Okay, if you do not have question, then I think we already run over 5 minutes. I think you are free to go.